So please tell me if my screen is visible.
Yes, sir, it's visible.
Okay, great. Okay, so so what I'll do is that I'll start the first session. I'll be talking about at the high level. I'll be talking about the SDKs, end-to-end AI stack, NVDIA AI stack, which is optimized for the GPUs, mostly for the deep learning, as well as some of the stacks. I'll be talking about the classical machine learning as well. And in the second session, which is scheduled to be from the 6 in the evening, I'll be doing hands-on session on the deep stream. Deep stream is the computer vision pipeline. So it's not just about the AI, but how you put the AI application into a pipeline, so that you can productionize those applications. So I'll be giving you demos, and I'll show you how to write the code so that you can play around with those code, and I'll show you how to you. So, and for me, so I'm working as sir has already mentioned, that I'm working as a senior solution architect, and my area of expertise is deep learning, classical machine learning. So I'll start my session. So before that, I'll just play a small video. So please tell me if it's you can hear the sound. Is the audio visible? Can you hear the sound?
No, sir.
Okay, I think let me share it first. Can you check if can you hear the sound, or you cannot hear the sound? How is it?
Still not it, sir.
Okay, I think there's some advanced sharing option. I think there's some issue. Okay, we'll play this video. Okay, we'll start the session anyway. Okay. Okay. Okay, so let's start the session. So that video essentially was just to highlight that what is the advancement in the computing and how AI is contributing to the betterment of the world, and how the computation when it comes to the GPUs, and how high-tech computing is contributing to the AI. Right? So as you might be aware that the main the GPU has contributed immensely to the advancement of deep learning, and to the some extent that the deep learning is data hungry, and the more you feed data, the deep learning has huge data requirement, right, as compared to classical machine learning. So for that, we need a processor which can process huge amount of data, and for that, when you compare it to the CPU, we need a highly specialized processor. That's where the power of GPU comes into picture. And because of GPU, the advancement of the deep learning has been possible. Right? To show you just one example, if you just BERT model. So in NLP, the BERT is one of the most popular model and one of the highly advanced model, and it's also a very large model. So in BERT large model, it just takes 2 minutes to train the BERT large model on NVIDIA A100 GPU. Right? NVIDIA A100 is the most advanced GPU, and it has 80 GB memory. I'll talk about that GPU. So it just if you take 8 A100 GPU, and if you want to train this BERT model, it will just take you 3.2 minutes. So that's the power of the computing. That's the power of GPUs. And with the deep learning, as you know, that you have to do lots of hyperparameter optimization. You have to do lots of experimentation, right? And let's say you are doing on some computation, and for that experiment, let's say if it's taking 10 hours, and you want to do some experimentation, and that experimentation has gone wrong, on that hyperparameter selection is not good, then again you have to start the experimentation, right? Then that effort has gone totally waste. So that's where we need to have some really good computing advances, so that we can iterate our experiment really fast. So, and it's just not about the training, it's about the inferencing also. Once your model is ready, once your model is good, but you need to deploy that model. And when more and more inferencing requests are coming, you need to serve those requests really fast. There also you need to use GPUs, so that you can serve many requests really fast. So one example you can see on the right side, that if you compare with the only, if you if you serve one model on the CPU, and if you compare the performance with the GPU, you get almost 400 times performance. So it means that if the one request takes X time on the CPU, then the same request take X by 400 times, right? So you get the 400X improvement in the inferencing. So your inferencing also, your prediction also gets really, really fast. So that's where the performance, the end-to-end thing comes into picture. And it's not just about the hardware. The acceleration comes not just by the hardware, but also on the software stack, that I'll talk about it now. So when I talk about the NVIDIA end-to-end software stack, so starting from the GPU, which is hardware, we have on the top of it CUDA layer, which is the software layer on the top of GPU. And on the top of it, we have any top application layer, which actually accelerates your popular deep learning framework, which is your, whether it's a PyTorch, whether it's MXNet, or whether it's TensorFlow. And also we have different kind of application framework, which is specialized for a different domain that we'll talk about it. And when it comes, and for training also, we have different training modules. So Tau module that I'll talk about it. So once you have trained the model, we have one thing called TensorRT. So once you have trained the model, we need something which can optimize that model. So because if you take the trained model usually is unoptimized, and if you put that model into the production, the first thing is that the model size is huge. It will take large memory, and the inferencing time will be really high, and it will not be production quality. So we need to optimize that model, so that that model can be of the business value, that model can be of the real value, right? That can be used in real world. So for that, we need to optimize that model. And how we can optimize that model? So we have one SDK called TensorRT that I'll talk about it. So through that, we can optimize those models. Once we have optimized our models, how we can deploy our models? We can deploy our models. We have Triton Inference Server, and that is fully integrated, supported with the Kubernetes. So how we can deploy our model? We can put this TensorRT optimized model to Triton Inference Server, so that it can it can give prediction, it can give inferencing on the GPUs on the batch request so that you get the really, really high throughput. And I'll talk about those numbers. And it integrates seamlessly with your Kubernetes so that you can have those fault tolerances and you can deploy in the production environment. Okay. So now let's have a look at the end-to-end stack and how this overall picture looks at. And so when we talk about machine learning or deep learning, so only one part of it is writing the code, or just understanding about this epoch and the basic algorithms, or that is part of the algorithm. But if you look at the whole picture, so that's just one part of it, right? So there are many components of it which actually productionizes your deep learning or machine learning code to the actual value, right? And this picture actually presents the whole stack, which makes your any machine learning or deep learning code into into a something which can solve a particular real world problem, right? So in this example, you can see at the bottom layer we have the hardware. So something, whatever you write deep learning or machine learning code has to run on some hardware, right? Or it has to run on either on the cloud or on the data center or on your desktop. But when we talk about the large scale code or large scale inferencing, we generally talk about the cloud or your data center. So you need to have hardware technologies such as GPUs. You should have some specialized some specialized chips such as DPU that is specially designed for processing the data. Similarly, you should have something like switches that actually that does not create the bottleneck. So you would have heard about something like multi-node training, right? When you are doing high data processing, high volume of data processing, at that time, training on one node is not enough. You need to train on multiple nodes, multiple machines. On each machines will have, let's say, 8 GPUs, and you need 8 those kind of machines. So effectively 64 GPUs, right? And all those 8 machines will be connected through network, but the network itself should not become a bottleneck. So it means that those network and switches, all those parts should be optimized, right? So that starts from that basic part is the hardware. On the top of it, we should have acceleration libraries, the layer which is on the hardware, right? Which is that is CUDA. And CUDA actually, CUDA is the kind of the remarkable stuff that actually for across the generation of GPUs, which makes it easily programmable for anybody, and you can program it in C++, Python, right? And on the top of CUDA layer, so CUDA forms the, so with CUDA, you can write application in the high performance computing or in the deep learning or in the classical machine learning also. And it has very good, very well integrated with the different kind of frameworks such as TensorFlow, PyTorch, TensorRT. So some of you would have coded in TensorFlow or PyTorch. So there you know that how to enable that CUDA backend. So you know that how to enable that CUDA backend, right? And that's where you set your device as a GPU if you want to train your model on GPU, and then you transfer your data on GPU, and that's where you train your mini batches or on data on GPU, right? So that you can parallelize it. Similarly, when we talk about other application framework on the top of this layer, we have application frameworks such as Metropolis. So DeepStream that I'll be talking about in the evening is a part of this Metropolis framework. So this application framework is used in the smart city applications. For example, applications at the airport, face recognition related applications, or safety related border security related applications. So all you can think of all computer vision related application. So this framework includes all of that. So if you talk about conversational AI related applications, so we have the Riva framework that I'll just briefly talk about. That framework also. In conversational AI, we have NLP, we have text to speech, we have speech to text. All of three comes into conversational AI framework. And then we have Drive framework that is for the autonomous vehicle. So this Drive framework is for the autonomous vehicle. So we have NVIDIA has partnership different vehicle manufacturers, so that different vehicle manufacturers for autonomous driving also. So we provide this accelerated stack, software and hardware stack for it. Similarly, for recommendation engine, we have Merlin. We call it the Merlin. And for the healthcare, we have Clara. Okay? So when I talk about this application framework, it means that inside that you have all the related models all the required things which is necessary to build cases around that, right? So let's say, for example, Riva. So you'll have all popular NLP related model will be there, pre-trained model as you'll have a Tower toolkit to train your model as well from your own data set. So we'll go in detail about that, briefly in more detail about that. And similarly, and we have a multiple way of hosting our model. So Triton inference server, I give you one example. Okay. Yeah. So now now the thing is that how you can get access to these models, right? And most of these models are free. And so these models you can get through NGC. We call it NVIDIA GP Cloud. So this is the web page you can see, NGC catalog. So you can log into NGC and you can get these models in the form of containers. So container is the like way to go, because all dependency, all the requirements is already packaged inside that. So you don't have to worry about dependencies. So once you have that Docker container in your machine, then you are good to go. So for example, in this screenshot, you can see that we have this container. Just example, PyTorch, TensorFlow. This is just two examples that I've captured here. So you can, so let's say you want to develop in PyTorch. So you can go it here and you can just get this PyTorch container rather than installing PyTorch from the scratch on your machine or creating VM. You just get it this PyTorch on container and you can start developing it here. And once you are done, you can just remove this container from your machine. So one advantage is that of doing this way is that first of all, these containers are highly optimized for GPUs. So you don't have to worry about any dependencies. Second thing is that yeah, a lot of time usually spends in creating, and it's very lightweight as compared to once you create virtual environment. So it's relatively lightweight. So all these models that I spoke about it, even application framework can be found here, NGC catalog. So I would request that so once you get time, just go and explore it. And so whatever you are doing, most likely you will find something relevant to here. So not just this application framework, along with some pre-trained model also. I'll just talk about that here. So you just have to create an account here and you can freely download those models. You can experiment with those models. You can train those models with your own data set and you can experiment. So one of the examples, just people detection, one example, gauge estimation, vehicle make identification. So it will just tell you which brand of car it is, heart rate estimation, language translation, punctuation. So just some very few examples I have given, but we have many, many more examples. So these are the pre-trained models. So these models, when I say pre-trained, so this has been already trained on the standard data set, but you can take this model and you can train on your own data set also. There's something like transfer learning. So you can take this pre-trained model and you can fine tune these weights on your own data set. So now the thing is that how I can fine tune this model, how I can fine tune this model easily. So one way of going about is that I can start with PyTorch, I can start with TensorFlow. We can do it here, right? In TensorFlow also, PyTorch also, I can take any resonate model. I can take any popular architecture like SSD or any popular backend I can take and I can start fine tuning it. But generally, for a beginner, somebody who does not have much experience, is quite cumbersome process. So that's where this transfer learning toolkit comes into picture. That's an NVIDIA's offering. We call it transfer, adapt, and optimize. Right? So this transfer learning toolkit, what it does is that it makes your transfer learning really, really easy. What it does is that you can take your model, pre-trained model, you can take from our NGC cloud, and you can use this toolkit to fine tune it. Right? And for fine tuning, it is just as simple as changing some of the few JSON parameters. So it's just changing the some parameters in the dictionary. So you just need to change that. Okay, how many layers I want to freeze, how many layers I don't want to. What is the learning rate I want to set? You don't have to write the whole code. You just need to change the structure in the JSON file, and that's all. So, and few commands you need to write, and that's all. You are able to fine tune this model, and that too on the GPU very effectively. So that's one thing also you can try. Right? So Okay. So let's go a bit on this Tau toolkit. Right? So this Tau toolkit, yeah. So so you can train your vision application also, train or fine tune, and your conversational AI application also, whether it's an NLP application or it's a text to speech or speech to text. So yeah, some of the examples of the models that I'm talking about, and some of these are the very common examples that people use, and also the some of the accuracy as well as the performance that I'm giving you. Right. So you can see the PeopleNet model. It detects person, counts the person from the scene. People. So these the results that you see. These are from the actual videos. The net model basically it does the segmentation. Basically, segmentation model it is. Traffic CamNet, it detects not just the person, it detects your vehicle also, type of vehicle also. Face detection, IR, infrared camera, how to detect the face, not just in the normal camera. License plate detection, LPR, all these models you can simply download it and use it. If you find that okay, it's not working on my data set, I will fine tune it. Right? That most of the time it happens that okay, because on new data set it might not work, it might not generalize well. Then we can fine tune it. The effort that with the transfer learning, that the biggest advantage in the deep learning that you can do the transfer learning. Right? So with the transfer learning, we can retrain those models on the new data set, and then we are good to go. And the number that you can see at the bottom, so these are the like for example A100 you see at the bottom. So these are the performance, that how many what is the performance, what is the how many frames per second you are able to process on this device, on this GPU. How many frames per second you are able to process. So imagine that you have deployed this model at the airport, let's say face detection or face recognition, and the airport and for security purpose. So you at that time you need to be really fast, because if some person you want especially if it is a security concern, and if you want at that time to be your inferencing to be really fast, it has to be almost real time. So you want that inferencing to be frame per second, the throughput has to be really fast. So for that you can use high end GPUs A100. You can see that 6,000 frames per second we can get the throughput. And for different model we have different rates, right? So these are the different benchmarking number that we have got. And also and when we talk about the model architecture and the backbone, so especially in the computer vision, you have this image classification, object detection, and segmentation. Three general type of problem if you see, and all popular architecture if you see, DetectNet, especially in the object detection, YOLO, quite popular, the people using right now. Segmentation also, UNet, mask RNN, is a popular architecture. Right? So all this architecture we have supported in the Tau toolkit also, and we have the pre-trained model also. And along with this this popular architecture, we have the backend also. So in the left side, you can see the GoogleNet, SqueezeNet, DarkNet. So these are the backends. So it means that on the object detection, or for example, the segmentation, you can take the unit and you can change the backend. So you have this flexibility. You can choose whichever backend I want, and you can similarly in this matrix you can select that which backend and which model is supported. Accordingly, you can get those models from NGC and our cloud, and then you can these models, all models are available free. You can use it and you can fine tune it. So it makes life really easy, because doing something from scratch, it takes lots of time, and most of the time you will not get accuracy, and lots of experimentation is required. So it's always good idea to make use of transfer learning. Start with something which has already been done, and then improvise upon that. It saves lots of time, that I've seen in my experience. Okay. Similarly, when it comes to speech, when it comes to NLP or speech recognition or speech to text, we have a set of models available. Automatic speech recognition, we have Jasper, QuazNet, CitriNet, Ngram. All these models you can go and explore. NLP also, as I mentioned, that BERT, we have BERT punctuation, BERT text classification, BERT Megatron, named entity recognition. all the models we have available. Similarly for text to speech also. So effectively it covers all three major domain of the conversational AI model. So all these fast pitch, all these models you can try out. And it's and all these models are in the containerized format, so you can try out. And the one good thing is that you cannot you just if you want to try out this Tower toolkit, and you have option, either you can try out in-house or you can try out on the cloud also. You want to try it on the AWS or Google Cloud, wherever you want to try out, you can try it out. All these models will be available there as well. Okay, so yeah. And one, so yeah, I'm just now giving you another like how easy it is to retrain it, the transfer learning, how easy it is to do it with the Tower toolkit. Or so let's say you have the PeopleNet model, correct? And that PeopleNet model, you have a data set previously you had trained that model with the normal RGB camera, but now you want to work that model to work on the IR camera. So you can easily feed that data set into the existing model and fine tune using this toolkit. Then the same model, after some iteration, you will need less data, and it will work. It will work on the IR data set also. The same PeopleNet model with some fine tuning will work on this. You can see that the left side is detecting the people in the RGB camera, but on the right side, you are able to detect the people in the IR camera. Right? But the only thing is that you need to train now with some IR images, same model with this toolkit. And this makes it really, really easy. Just some command line you need to change. Similarly, you can add new class as well. So you can, let's say, you can add new class. Previously, it was a new data set, and you can add, like, if you have 3 classes, you can add one more class as well in this transfer learning. So there's different ways of just transfer learning. I'm just talking about it here. And some questions. Okay, questions I'll take at the end. Okay, so one important thing that we should be aware of is the model pruning. Right? So it's while we are training the model, so that whatever model that we are training, one part is accuracy, but we should also be aware that our model size should not be really large. The implication of that is that the one is that the memory increases, the model size is big, it takes large memory. Second part is that your inference time is higher. So how we can reduce the model size? The first, the one of the way is the pruning. So what the model pruning is? Model pruning is that can we remove some redundant connections in the neural net? And how we can do that? There are many ways. I'll not go in detail. There are sophisticated ways to do about it. So effectively, what we are trying to do is that in model pruning, what we do is that we remove some of the connections from the models, so that the model size reduces. And once we remove the connection, again we retrain the model. So what happens that we try to maintain the accuracy, but the overall model size is reduced. So what happens that with this all more or less similar accuracy, our throughput, our inferencing prediction speed is increased. So how to achieve that pruning? That pruning, and in our Tower toolkit also, this pruning is also one command line we can achieve it. So we don't have to write any elaborate code for this, the way it will happen in PyTorch or TensorFlow. If you imagine, you have to write lots of code for this. But here the pruning part should be really, really easy. We should be, we can achieve through some flag. This part you can achieve. So these things are important when you talk about making deep learning model, which is of production quality. Right? So model which can actually serve in the real time scenario. Okay, these things become important when we talk about some production level quality, because most of the time what happens that, let's say we build the model, it's giving good accuracy, but the moment it goes for the testing part, the moment you deploy it, but it gets discarded because you get the feedback that, okay, no, your model is accuracy is good, but your throughput is really bad. Your inferencing time is really, really this time is not acceptable, because you need to do something about it. So at that time, we need to come up with a strategy such as pruning. Can I prune so that my model becomes small? At the same time, I do not lose my accuracy. So these are the strategies that we come across. Similarly, another strategy is this quantization. So quantization is also important when we talk about Similarly, let's say you want to deploy your model at the edge devices, right? So when we talk about edge devices, so let's say you want to deploy some deep learning based model, not at the data center, not at the cloud, but at the remote far location. Let's say at the at the oil drilling places in the mid of ocean, or let's say uh, at the far flung places, right? At that place, you cannot rely on the communication. You cannot rely on the cloud computing. Only thing you can rely upon is that at that place only you need to compute. So edge computing. So at that time, so your hardware resource is limited. You cannot have that 64-bit floating point computation. You need to optimize in terms of bits. So how you can do about it? We need to be at that time. We need to be, I need to make sure that the weights that I'm using, that has to be, can I make it FP16 from FP32? But if I make it direct, or can I make it int 8? Can I make it int 8? But if I directly make it, if I just truncate it, then my accuracy will drop, right? It's just if I simply truncate from 16 float to int 8, then my accuracy will be really, really dropped, because I cannot simply convert it to a floating to integer the way on the left side it has been shown. So what we need to do, so there's a technique, it's called quantization aware training. So what it does is that, so while you are training your model, you need to take into account of this part, that okay, if I quantize my FP16 to int 8, right? While, so at the time of training only, you just tell your model that okay, I intend to quantize my model, but whatever the loss is coming, the model should accommodate that loss while training itself. Right? So that way, your accuracy drop will not be that much other if you just do the post-training quantization. So this process is also elaborate, but with Tower Toolkit, you can just enable it using just one flag. So this is also one of the techniques that you can optimize once your model has been trained. Now you want to increase the performance of the model. One thing you can try the pruning. Second thing you can try the quantization. How you can try it? Through the Tower Toolkit, you can enable this flag and it will just do in one line. So these are the various strategies that I'm talking about that you can do very easily, and that will give you very high throughput, and that will make your model, that will make your whatever model that you have built through your hard work or research to be of value and to be useful in the real life situations. Similarly, something automatic mixed precision, you might be aware of this thing because it's already in PyTorch also. So automatic mixed precision, what means that, so see, while training, so generally by default, if you do not provide anything, so all the all the variable are taken value as a FP32 bit. So at that time, so if you imagine, so if you compare FP16 versus FP32, the memory footprint of FP32 will be double. So can we do something so that at least some calculation can I do in FP16 and some calculation can I do in FP32? If I can split my calculation in these two, so that's why we are calling it automatic mixed precision. Can we do this? If we can do this, then we can optimize it, right? So we can at least, if doing this, we can optimize our memory footprint, and this way we can not just memory footprint, we can optimize our performance also. We can optimize our inferencing speed as well, right? So now the question comes, okay, which part I can make it FP16, which part I can make it FP32. So generally, when we talk about loss, when we compute the loss or summation, all these aspects we generally keep in FP32, because based on loss, we do partial differential and we calculate the weight updates. So that's why we don't want to do any underflow, overflow there. So that's why we keep it FP32. But general convolution matrix multiplication, we can keep it in FP16. So generally, what we have seen is that if we from FP32 precision, if we come to automatic mixed precision, we can drastically reduce the training time. You can see that on the right hand side, from 28 to we have got it 18, right? So that much drastic reduction we can do in the training time, but the accuracy will not lose much. Right? So that's the biggest advantage we have. This is also one of the techniques that you can try while training itself. So your training time will reduce. And in the Tau, how you can enable it? So on the bottom right, you can see that Tau model, and you just need to enable this flag. Use AMP. So the moment you enable this use AMP, you write this flag the way you use in any Linux command. Then while doing this, your model is now doing automatic inspection, and you will notice that okay, my training time has reduced drastically. My per epoch time has reduced drastically. So in the evening, I'll talk about deep stream. So to give you one just a brief overview now. So we'll go in deep stream. So I'll just I'll ignore it now. So yeah. So similarly for TensorRT, I already spoken about. So TensorRT is another framework that we have. Is for optimization. So let's say you build your model using TensorFlow or PyTorch, MXNet, or ONX runtime, or whichever thing you choose. Now to deploy it on various GPUs, we need to optimize that model. So here TensorRT, what kind of optimization it does? It does parallelization. So especially it is more useful in convolutional networks. So because there are many layers in the convolution, so where fusion of the layers is possible. So it fuses many layers. It just tries to do parallelize it. So wherever parallelization is possible. So TensorRT is an optimized library. So you can use it to make it even fast. So this TensorRT is integrated with your TensorFlow. So you can use it within TensorFlow also. So it's also one of the techniques that you can try it out to make your model even faster. So if you just take your TensorFlow or PyTorch model and you just serve it, right? So your inferencing time will be more. But if you just convert that model using TensorRT and then you do the inferencing, then you'll see that your throughput will improve. Your training time, your inferencing time will reduce. You will get the quick prediction. So that's another optimization that we have, this TensorRT library. Right. Similarly, now let's talk about this. So we have covered the aspects of that the GPUs and some of the framework that I've spoken about, that NLP related framework, and also spoken about the deep stream that I'll talk in the evening, and I have spoken about TensorRT. But now the thing is that how you once you have optimized the model, and once you have done this pruning, quantization aware training, and AMP, but ultimately we need to serve this model. So when we serve this model, so model serving itself is that we call deployment. That itself is a challenging part, because see many people deploy model in a different framework. So if you see in a corporate or in a company, so there's a one data science team which actually develops model, and there's a separate team usually which is a inferencing team that actually takes care of this deployment part, right? So let's say data science development team has created model in TensorFlow, or some other data science team has created model in PyTorch, or somebody else has created in MXNet. Now, how deployment team will make sure that, okay, I'm able to serve all those kinds of models. So in deployment has its own challenges, because it has to take care of multitude of platforms. So because data scientists can use multiple platforms to build the model. So how we can how we can do the deployment so that it can take care of all these deep learning frameworks. So it has its own challenges. So that's where our Triton inference server comes into picture. It tries to solve all these challenges. So the deployment and deployment also, once you deploy your model, so it has its own challenges. You can deploy on CPU, you can deploy it on the cloud, you can deploy into the GPU, and you can have, once you deploy your model, so you can have different type of query. One will be real-time query. So you just you send query to the model, and the model has to respond immediately. That's a real-time query. You have the batch query also. You just send a batch of data, and the model does not have to respond real time. And then similarly, you have the stream kind of query, right? So so different kind of queries are there when it comes to model serving part. And similarly, and for model serving, there's another aspect that we need to be aware of, is that the hardware utilization. So especially from the let's say you have some hardware, that you have deployed, and but that if that hardware is not being utilized at the 100% capacity, then then the company is losing money there, because that hardware has to be 100% utilized. The utilization has to be really effective, so that if the hardware has capacity, let's say, to serve 10,000 requests per second or 10,000 queries per second, and if it's 2,000 requests per second only, then it means that we need to do something there. Otherwise, we are losing money in that hardware, right? So that's where we need some kind of framework that solves this kind of problem. So that's where our Triton inferencing server have these answers for these questions. So yeah, and that's where Kubernetes integration comes into picture. So when we talk about the large scale deployment, so you need to have fault tolerance there. If your one server is down, the other server should come up, so that you can provide uninterrupted service. So the Kubernetes integration has to be there, and our Triton inference server integrates well with the Kubernetes. And along with that, it should support MLOps related operation also, because you need to have model related information always, like what is the model performance, and how I can dynamically upload the model. Let's say you want to change your model into production. So how I can do A to B testing. So these kind of things, how I can do without bringing my service down, how I can make another model live. So all these MLOps related operation, how can I do? And the biggest thing about this Triton inference server is that it's open source. So its code is freely available, and you can try it out. If you want, you can change it. And this is the architecture of this Triton inference server. So it can run on GPU also, CPU also, and you can all these metrics, utilization, throughput, you can get, and you can and it has the mechanism that's called dynamic batching. So what it does is that you send it thousands of requests, right? And it has its mechanism that's called dynamic batching. It makes optimal batches and distributes those batches on the GPUs, so that it tries to utilize the maximum of those GPUs and gives you the maximum performance, maximum throughput, so that you see your hardware utilization is maximum and you get the fastest request served. And it supports all major framework. You have this TensorFlow, ONX, PyTorch. You build your model in PyTorch, TensorFlow, and you can serve it here. So you can, and with this Triton inference server, either you can serve in GCP, Google Cloud, or AWS. Okay. So I've covered, so starting from building the model, fine-tuning the model, optimizing the model, at the same time, also serving the model. So now let's talk a bit more about NLP related applications. So in NLP related applications, so NLP and conversational AI related application. So we have NVIDIA NeMo. You can NGC container. You can GitHub also. You can look at just GitHub link. You can say open source. Again, it's open source. You can have full. You can just look at this code and you can explore it how it is. And it has three major libraries: NLP. ASR, speech to text, and TTS, right? So speech to text, text to speech, and NLP. And NeMo is based on this PyTorch and PyTorch Lightning, and it has many pre-trained model available, voice recognition, speech synthesis, NLP, and all these models. So I would request that you can just go to this GitHub page, NVIDIA NeMo, you search, you will get all this model as well as code also freely available. You can try it out, and you can see, and it's very easy. Code is, and in Python also you can just you can start coding by just import NeMo, and you can just all pre-trained model. You can just 2 lines of code and you can start using this pre-trained model. So just one of the example is, for example, NLP. You can name entity recognition. You can just BERT, large, so all translation, all this model, just 2 or 3 lines of code. You can just start importing and you can straight away use this pre-trained model. So, and if you wish, you can fine tune again, as I previously mentioned, as with the computer vision related models, same here. You can take this model as it is. Otherwise, you can fine tune it also. But the best thing is always is that in deep learning, the best thing is that always start with something which has already been done, the transfer learning. That's the best idea. I would recommend. because that saves lots of time. Because if you do something from scratch, the first thing is that it takes you lots of time. But if you start something transfer learning approach, you take something which has already been done, you train that on your own data, then it's really effective. It takes less time, and then you get very good accuracy. Right? Similarly, for ASR also, you can see that speech to text, speech classification, speaker recognition, all these popular models have, even the optimized pre-trained model name you can see on the right hand side is available. So you can just go and download and start using it. And the code is very simple, and GitHub code is 2-3 lines of code. Sample codes are also available there. You can just go and see. Similarly, and multiple language, and all these is available free. See, build and train models in 3 lines of code. So and just multiple language, ASR, all these popular, all these multiple languages are supported. NLP, if you want to NLP, not just English, but Spanish, Russian, Mandarin, German, and also especially in NVDIA India, we have started in a big time, especially for Indic language. Also, we have in-house trained model for Indic language, also Indian languages for text to speech and ASR. So and similarly for so these was on the speech to text NLP side, and NLP and conversational AI. Similarly, for people who are interested in the imaging imaging in the medical area, so here also we have one popular SDK which is used a lot by the industry, especially like industries in the medical imaging such as GE, Siemens, or used a lot by not just the industry but the universities also. Because if you see, there's a huge scope of scope of AI in medical imaging, and it's already being done. And you can see that some of the popular model which is especially used in medical imaging. So for example, brain tumor segmentation, especially these are the model for like application of image segmentation in the medical imaging. So similarly, vision transformers, medical image medical object detection. Same in the COVID time, we have this oxygen level prediction. So all these models, we have this framework called Monai Clara, NVIDIA Monai Clara, where we have these pre-trained models available that the people can use it, and that makes it easy to use. Okay, so for medical imaging, the challenge is different, because here the data format is different. The image is not a normal RGB format image. It's slightly different, and here the accuracy is also the demand of accuracy. The criteria precision has to be really high, right? Precision has to be really high. So at that time, we need different kind of framework. Simple PyTorch kind of framework, TensorFlow kind of framework is not enough, right? So that's where this a framework, Monai framework, has come into being. So Project Monai is a collaboration of industry expert as well as academia as well as NVIDIA. So it's initiated by NVIDIA, and then it's open source essentially. So it is essentially for medical imaging, and it's based on PyTorch. So basically, it's a extension of PyTorch, and especially designed for medical imaging. So people who want to do deep learning research or deep learning work in medical imaging, I would request to go and explore this Monai, because it has a special data format. It handles special data frames or data formats or data loaders, which actually is able to take care of this medical image data. So you can explore this Monai framework also. And this Monai framework is well integrated with our NVIDIA Clara, and it's gaining lots of popularity. And this Monai, under Monai framework, which essentially is a PyTorch. If you know PyTorch, then Monai is very easy, since it's a PyTorch base. It's well integrated with our all other toolkits, all other SDKs. For example, DeepStream, Triton, which I mentioned, Triton for inferencing. Let's say Monai, you develop medical imaging application, and you want to do inferencing, do prediction. You can just deploy your model on the Triton server, which I mentioned. Let's say you want to optimize your model. You can take this Monai model and optimize it to TensorRT, TRT, which I mentioned, right? And it is in this Monai framework, you have this AI data labeling. So active learning, you would have heard this word, right? So active learning. Active learning is a framework where you do the data labeling with the help of deep learning or machine learning. So user label the data, at the same time you get the prediction from the model also. So iteratively what happens that, so you have to label less and less data. So the first iteration, the model gives you data to label, right? So which the model is less confident about, and over the time that the process goes on. So this is the active learning framework. So under Monai you have this label support also. So so that is called Monai label. So you can explore this also, especially people who want to do AI research or AI work, or who want to who have aspiration to go into the companies who work in the medical imaging. So you can explore it. And this Monai framework, not just companies are using, but all respected names, all respected universities are using it, especially their medical imaging labs, they are using it. So it has AutoML in it, starting from active learning, data labeling to deployment. Everything is integrated in this Monai framework. And it's the good part is that it's well integrated with the GPU. So highly optimized for the GPU. So whatever code you write in Monai, so you can easily run on the GPU. So you can imagine that in active learning, so Monai label. So you actually, you are while doing segmentation. So you have some model, and model is making some prediction, but at the same time, you also want to correct it. That's where this iterative process will go on. So at that time, it's quite important that it has to run on GPU so that that process is really fast. So that's where this multi-GPU support is there in this Monai label framework. So you can explore this as well. And now I'll just briefly quickly talk about this rapid NVIDIA Rapids. So previously what I spoke about was on the deep learning side, but let's say people who want to do classical machine learning, who wants to do build a model in XGBoost or tree-based model, or who want to do normal, just graph-based algorithm or data frames. So what kind of, how I can accelerate on the GPU, right? So for that, we have this rapid, so again, it's open source library. So NVIDIA initiated this, but it's open source. You can just have a look and go over it. So it's all accelerated by, all is accelerated on the GPU. So all these popular XGBoost algorithms, you can run on those algorithms on the GPU. You can, QML is a library then where all popular machine learning algorithm is parallelized. So you can just run those, whatever algorithm was running on the CPU, you can run on the same on the GPU basically. So the QML takes care of that. In the backend, it just parallelizes those algorithms so that you can run on the GPUs. Similarly, for the graph analytics, you can use QGraph. So this rapid is for the classical machine learning, or also for the normal data preparation, data processing, for QDF for data frame processing. Okay. So you can try this out as well. And for cybersecurity, so in this talk, basically, I'm just giving you the heads up on the different frameworks, so that if some area interests you, you can go and explore it. So cybersecurity, if your area of interest is cybersecurity, you can try out the Morpheus framework. And when I say framework, why it is easy to do that? Because all the basic thing has already been done. So you know that cybersecurity. In cybersecurity, usually the thing is that you need to understand the pattern of the data, and the pattern of and in cybersecurity, the pattern, the event code of the network, whatever the network packets are coming, that sequence is important. So the techniques of NLP, the techniques of language processing becomes really important. So those kind of techniques can be used, or those kind of models are used in the detecting the cybersecurity threat. So in this Morpheus framework. So this again is you can try it out. So right now it's in the early access program. You can try it out. So in this framework, basically you just have to pass your whatever network data, whatever your stream data is coming to this Morpheus framework, and it will utilize internally. It will utilize your rapid framework, which I spoke about, and it will use deep learning model, and you have option to choose which model you want to use. So we have pre-trained model also. For phishing detections, or predictive detection, so predictive maintenance or phishing detection. So those, all those kind of popular cybersecurity threats, we have the pre-trained model. You can either use them, or you can bring your own model also in popular framework, and you can just put this model in the framework, and you can deploy it on the Triton inference server. So it provides a framework where you just have to use this Morpheus, deploy it in machine, and then it just 24/7 it will this flags you this cybersecurity threats in your network, and then based on that you can design your workflow that okay, if some threat is detected, then what action to take, then that workflow also you can design. So and it also gives you the choices that okay, because all this data processing requires special hardware. So what it does is that some part of it, there's especially the deep learning part or data processing part, it offloads to the GPU, and some of the other parts, the networking part, it offloads to the CPU, offloads to the DPU, data processing unit. Right? So that kind of optimization also it does. Okay, so now I'll just conclude my talk. So I'll just give you some insight on the GPUs, the accelerator. So the type of GPU and how to use in the deep learning. So generally, when we talk about the GPUs, so as you know, the difference between CPU and GPU, right? So GPU has many processors parallel, so you can parallelize you can parallelize the programs, and it's especially efficient in the matrix multiplication. That's why matrix multiplication and addition. That's why it's so much popular and so much fast in deep learning workloads, right? And so much, almost 1,000 times faster than CPUs when it comes to deep learning workloads. Right? So especially, and in the CPU also, in GPU also, there's something called tensor core, which actually is even further optimized for the matrix multiplication. Right? So when we talk about the GPUs, so some of the GPUs that so A100 is the most advanced GPUs. This Ampere architecture, we call it Ampere architecture A100, and so it has 80 GB RAM. So when you talk about 80 GB DRAM, so it means that you can create large sizes, so mini batch sizes. So when you are training your model, so one thing we need to be aware is that okay, I can feed more and more batch sizes so that my GPU utilization is high. So and you can, and even your data size, you can put bigger and bigger data on these GPUs. And similarly for A30 is this mainly used for inferencing as well as the workloads where you have to do inferencing also, as well as you want to do continuous training also. So those kind of workloads we use this A2 GPU. We generally use in the scenarios where our main intention is to do the inferencing. Our main intention is to use the prediction part, where we don't want to train the model, but we just want to make use of the GPUs to just make the prediction part. And this A40 and A16 GPUs are mainly on the graphics side, so mainly designed for the graphics related workloads, where especially ray tracing, call it RTX GPUs. So where the ray tracing, we call it ray tracing technology, where the ray interaction of the light with the real world object, so that it looks realistic. So that's where this RTX ray tracing technology come into picture. So those are the on the graphics end. So yeah, so some of the GPUs that so for AI related workloads, so the best one A100, you generally for the high end server people use for big models training. That is the one usually people use for it, and for inferencing is the A2, the GPUs to go for it. So that was from my end. So any questions you have? So in the evening I'll talk. It'll be more on the hands-on side. So any questions? Okay, so I can see. Okay, so PyTorch container from NVDIA is different from one we get from PyTorch. So one thing, see, the difference is that the PyTorch container from, the difference is that you don't have to worry about, since it's a container, right? So you don't have to worry about the dependency and all that, right? and you don't have to worry about the dependency, and it's also optimized for your GPUs. Correct. So generally, what happens that once you get it from PyTorch, it's fine. I mean, usually major library wise there will be no difference, but the difference comes into picture when it comes to that this dependency, that dependency, that kind of problem you will not face here. Okay. We can integrate these pre-trained model in Python, or we need to use NVIDIA framework to use this. No, this you can integrate this. So we can integrate this pre-trained model in Python. So you can integrate this pre-trained model in. So where the question is not. So the question is, you can integrate this pre-trained model in Python. Yes, you can integrate this pre-trained model in Python, but so you need to use NVIDIA. So the thing is that where you want to use it, right? So this pre-trained model, you want to make prediction, right? So when you say that, let's say people detection model, so these pre-trained model, you can use, let's say you want to use in Vision pipeline, you can use in DeepStream, or you can use in Triton Inference Server if you want to do the serving part. So, but since all these things are open source, so it does not matter that where you are using it, right? So it's not, since all it's open source, so you can use it either using, so all this in Python only, but it does not matter whether you use NVIDIA framework or Python, right? Since it's open source. Correct. So the thing is that with NVIDIA framework, it will be easy to use because it's a build tested on that. So let's say you use PeopleNet model in DeepStream, you just have to put that model in the config file and it will just work seamlessly. In Triton Inference Server, you just put the path of that model, it will work so seamlessly. And all things are open source, so without any issue, it should work. Okay. Can we use Tau processing for Tau toolkit for image processing? So Tau toolkit is mainly for transfer learning. You can fine tune your model, using Tau toolkit. Image processing, when you are saying image processing, we have a different thing. I'll just send you detail of that, so that image processing, we have a library where we can optimize image processing on the CPU, not OpenCV. We have I'll tell you the name. On that, you can optimize those basic image processing on the GPUs. But Tau toolkit you can use for transfer learning. You can fine tune the model, but you can fine tune the model, computer vision related model, all the VGs, all the backend popular backend model, all the whichever model you choose, right? Whether it's an NLP model or it's a computer vision model. Okay, I have some pre-existing algorithm that exists in R script. Can we make it parallel using code application with Python and JetNumPy without modifying the actual script? No, you need to, that part, you need to, with R, I'm not sure. I need to check on that part, that how you can do it, that without changing this, without modifying, how you can parallelize that. I'm not sure. I cannot comment on this. My question, if I want to fine tune, can I do in Python? Okay. No. So if you want to fine tune, if you want to fine tune those model, then you can use you have to use model in Tau toolkit is the way you can fine tune the model. And the reason is simple, right? So those model, let's say PeopleNet model or the vehicle detection model, right? So those models you can take as it is. It's in TLT format, the pre-trained model, and you can with the Tau toolkit, you just need to provide the data, and you just need to like provide how many layers or on which parameters you want to fine tune. You just need to give those details, and then you can fine tune the model. But you have to use the Tau toolkit there if you want to fine tune those models. Yeah. If you are using pre-trained model. Because the reason is simple, that because that model has been trained in Tau toolkit itself, so it's just a formatting thing. So because that model has been trained in the Tau toolkit, so within same framework, it has to be fine-tuned. And because that fine tuning becomes really, really easy, because it just some set of parameter, it has to be changed, and then it's done. And one thing is that once that model is trained, then it you can be sure that it's optimized. You can try various things such as pruning or quantize aware training, or which of some of the things that I've spoken about. Okay, so that was from my side. So if you have any questions, you can ask me. You can just email me here, and I'll just and if you want to ask anyway, evening we'll just talk in the evening as well. You can just connect me on this also, and one more thing that and if you see the thing is that one important thing is that in machine learning, what we generally tend to do is that we go really really go in the maths theory. I understand that really important. We have to do that. We really should go math and math into that. I have been there. I have done that. We all should do that. But at the same time, we should never forget the big picture. We should always keep end-to-end picture in the mind. Whole picture, that how from starting from the hardware to the where the model is being used, because ultimately that whatever the model we are building, somebody has to use it, right? Because the AI boom that has come, ultimately it has to serve some real world purpose. Only then it can go on, right? So that's the